Okay, class. Hey, so we are now on our second practice problem set when it comes to electron configuration. This is going to more focus on our second step, dealing with quantum numbers. Okay, so in our first video, we set through and just was able to identify what electrons go to what orbital. On this video, we're going to get more specific on clarifying how many electrons are in each orbital and not just saying, hey, there's some present in this orbital. So just to reiterate and re-emphasize from our last video, you got to make sure you know your orbitals. Remember, your s orbital has one suborbital and 2 electrons. Your p orbital can have 3 suborbitals and 6 electrons. Your d orbital can have up to 5 suborbitals and 10 electrons. And your f orbital can have 7 suborbitals and 14 total electrons. Also, make sure you're able to use your electron orbital diagram, which will be on the screen now. So, the type of questions we're going to be seeing is to determine the full quantum number for each of the following elements. Notice I said the full quantum number. There is a shortcut to writing these out, but because we're just now learning them, we're going to write the full number, and we're just going to go from there. We're not going to get in deep enough to do the shortcut version. So, first element is sulfur. So if I want to write the quantum number for sulfur, we know sulfur has 16 electrons. So I'm accounting for 16 electrons. We know sulfur has 16 protons, and if it's neutral, that means it has 16 electrons. So that means I'm accounting for 16 electrons in my quantum number. Starting off, we're going to start off like we all of our other ones with 1s. That is going to fully fill my s orbital, so I'm going to have 1s2 for a total of 2 electrons so far. Then I'm going to go to my 2s orbital, and that's going to be 2s2 for a total of 4 electrons now. 2 from the 1s, 2 from the 2s, so a total of 4. Okay, we want 16, so we can fully fill this one up. If I put 6 electrons on my p orbital, that gives me 2p6, and that gives me a total of 10 electrons. Then we go to our 3s orbital, fill that up, and we got 12 total electrons now, so 3s2. And we need to count for 16, so we're at 12. So we can finish it up with our 3p orbital, but we don't have to fully fill our p orbital. Because it can hold 6, and we only need 4, all we have to put is 3p4. So that gives us a total quantum number of 1s2, 2s2, 2p6, 3s2, 3p4. And that's it on that one. Okay, so let's do one with a little bit more electrons. Let's go with cobalt. Cobalt has 27 electrons in its neutral state. Okay, so let's start out 1s2. That has 2 electrons. 2s2, now we've done 4 electrons, total electrons. Then we go 2p6. That gives me 10 total electrons. 3s2, we're up to 12 total electrons. 3p6, we're up to 18 total electrons. Now we're into some new territory that we weren't on the last one. So we're at 18 electrons. We need 27. So now we go to 4s. Okay, we fully fill up the s orbital. That gives me 4s2. So we have a total of 20 electrons. We need 27, so we got to go another step. Okay, so now we go to our 3d orbital. Remember, our d orbital can hold up to 10 electrons. We only need 7 though. That gives us a total quantum number of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. And basically what's the point of all these is just trying to show you like, hey, we can account for every single electron in an atom with just identifying a certain quantum number. Going on to potassium. That's going to be our next one. It has 19 electrons. So we're going to start back out at 1s2. Then we're going to go 2s2. That's going to give us a total of 4 electrons. Then we're going to go 2p6. That's going to give us 10 total electrons. Then we're going to go 3s2 for a total of 12. Then now we're at 3p6. We need 19 electrons, so we can fully fill this up. So we got 3p6, and that gives us a total of 18 electrons. 2 from the 1s, 2 from the 2s, 6 from the 2p, and 2 from the 3s, and 6 from the 3p. So that's 18 total electrons. Now we're to our 4s. We only need 1. We don't need to fully fill it up. Because we're at 18, we need 19 electrons, so that's going to be 4s1. That gives us a total quantum number of 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now let's go down to 10. 10 has 50 electrons, so we're going to go a lot farther on this one. So starting out again, 1s2, 2s2, 2p6. That's going to be our first 10 electrons. Then we're going to go, let's do our next set of 10. 3s2, 3p6, 4s2. We've done these enough so that we're pretty good with knowing where these electrons came from. So now we've got 20 electrons. Next, we're going to go to 3d10. That's going to give us 30 electrons. So our 3d orbital's next, and we fully fill it with 10. And now we're getting into some newer territory. So we've done 3d10, 30 electrons now. Now we're on the 4p orbital. We need 50, so we can go ahead and fill this one up. So that's going to be 4p6 for 36 total electrons. Then we're going to go to the 5s orbital and fill that up to get 5s2. That's going to give us 38 total electrons. And then we go to the 4d orbital. Okay, that's going to give us 48 total electrons if we fully fill that up. So 4d10. And we need 50, so we need 2 more. So that's going to be, our next orbital is 5p. And we only need 2 in there, so that's going to be 5p2. So we can think of this as our full quantum number as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p2. Okay, last one. Now we're going to bismuth. Bismuth has 83 electrons, so we're going to go significantly farther. Okay, let's start out with our first 10 electrons. 1s2, 2s2, 2p6. So there's 10. Then we go to our next 10. 3s2, 3p6, 4s2. So now we're at 20 total electrons. Then we go 3d10. So now we have 30 total electrons. And then now let's work our way up some more. Okay, so we're at 3d10. Now we go down to 4p6. That's 36 electrons. Then we go down to 5s, fully filled up. That's going to be 5s2 for 38 electrons. And then 4d10 for 48 electrons. You can go ahead and look back at our last one to see where we got all those electrons. And then we got 5p. So this is where we get to some new stuff. On our last one, we were only able to fill up 5p2. Well, we need a total of 83 electrons. We're at 48, so we can fully fill this shell. So now we go 5p6. That's going to give us 54 electrons. Then we go to 6s. We can fully fill that, so 6s2 for 56 total electrons. Then we go to 4f. Okay, remember our f orbital can have 14 total electrons. So let's add 14 onto that. We were at 56. Now we are at 70. So we went from 6s2 at 56 electrons to 4f14 at 70 electrons. We need 83. So now we go to 5D, fully fill that up, is 5D10. That's going to give us 80 electrons. And then we just need 3 more, and we're just going out of our 6p orbital. So that's going to be 6p3 for a total of 83 electrons. Now, let's say that mouthful is its full quantum number. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 7f14, 5d10, and 6p3. I hope this helped you out and gave you some more information that you need on practicing these types of electron configuration problems. So you started out with just naming the orbital. Now we've gone to naming specific electrons on the orbital. In our next video, we'll go into identifying the spin of those electrons on those orbitals. And saying all that, bear with me through these. I know they're hard, and keep up the good work in the class. See ya.